Recall that in part 1 of this video, we solved the equation y prime minus 3y equals t, y of 0 equals 0, and we got the solution y of t equals negative 1 over 3t minus 1 over 9 minus 1 over 9 e to 3t using the linear differential equations method, using undetermined coefficients, and using annihilator. So in this video, we'll solve the same equation using Laplace transform. So we have y prime, well, y it's a function of t. We should write y prime of t minus 3y of t equals t, or we just use the shorthand notation y prime minus 3y equals t, knowing that y is a function of t. So let's apply Laplace transform to both sides. So what are we going to get is Laplace transform of y prime of t is a function of s minus 3 Laplace transform of y of t as a function of s equals Laplace transform of t of s. Now, Laplace transform of y prime of t is equal to s y of s minus y of 0. This is learning properties of Laplace transform minus this new notation. So I write minus 3. And Laplace transform of y of t of s, I can write it as capital Y. So as you can notice, this is lower letter y and then capital Y of s as the Laplace transform. And then using the table or using the definition of Laplace transform, we calculate Laplace transform of t, which is 1 over s squared. So knowing that y of 0 is 0, it was given in initial conditions. If we factor out y of s, we get y of s times s minus 3 equals 1 over s squared. Or y of s equals 1 over s squared times s minus 3. So y of t, which is the solution that we are looking for, is going to be the inverse Laplace transform of 1 over s squared times s minus 3. And in order for us to calculate this inverse Laplace transform, we have two ways. We can have 1 over s squared times s minus 3 using partial fractions. So I can write a over s plus b over s squared plus c over s minus 3. And if we calculate, if we find a, b, and c, we can calculate the inverse Laplace transform. So I'm going to do that to remind you how to do partial fractions. So it's a times s minus 3 plus b times s minus 3 plus c times s squared. So if s equals 0, we get 1 equals negative 3b. So we can immediately calculate b as negative 1 over 3. If s equals 3, we are going to get 9c equals 1, so c equals 1 over 9. And I would like to find a, and I'm out of zeros of this equation, right? Because the choice of 3 and 0 were to get those 0, but I can make up any number. So I'm going to set s equal to 1, so we get 1 equals negative 2a minus 2b plus c, but we know b and c, so it's 1 equals negative 2a plus 2 over 3 plus 1 over 9. I'm going to pause this and solve for a. And I got a equals negative 1 over 9. So basically, this relation here is 1 over s squared times s minus 3 can be written as negative 1 over 9 times 1 over s minus 1 over 3 times 1 over s squared plus 1 over 9 times 1 over s minus 3. So y of t is the inverse Laplace transform of t, so it's negative 1 over 9 times inverse Laplace transform of 1 over s, it's 1, minus 1 over 3 times inverse Laplace transform of 1 over s squared, it's t, plus 1 over 9 times inverse Laplace transform of 1 over s minus 3, it's e to 3t. So if we compare this result with what we got before, we get the same thing. Another method that you could use to calculate this inverse Laplace transform, so instead of doing partial fractions that we did here, right, these were partial fractions, we can use convolutions. Let's see, do you remember convolutions? Inverse Laplace transform of an Laplace transform function times another Laplace transform function, it's equal to the function f of t convolution g of t. So in our case, we have inverse Laplace transform of 1 over s squared times 1 over s minus 3. So basically it would be, what is the inverse Laplace transform of 1 over s squared? What function has the Laplace transform 1 over s squared? T. Convolution, what is the inverse Laplace transform of 1 over s minus 3? E to 3t. So then, in order to calculate t convolution e to 3t, we do integral of 0 to t of f of t minus v, so this would be t minus v, times g of v, so it would be e to 3v, everything dv. So let's calculate this integral, and let's not forget that we have to integrate with respect to v. So this t that we have here is going to be considered as a constant. So I'm going to pause and calculate this integral. So I calculated the integral by separating into two integrals. I got this integral, and then I got this integral. Now, because our integral is in v, and if we want to use the integration by parts, we introduced that u and v, so I didn't want it to be confusing. I actually used another notation of integral of fg prime is fg minus integral of f prime g. I wrote as my g prime e to 3v over 3. If we differentiate this with respect to v, we obtain e to 3v, so it's okay. So now that I have f and I have g prime, I just did the product of v and e to 3v over 3 here, and then minus v prime, which was 1, so that's why I don't have this term here, and then times e to 3v over 3. So when we compare, so basically at the end, I got y of t equals the same thing as before, just compare these two. Maybe their location is in a different position, but it's basically the same thing. In this video, I'm going to solve the same equation as we did before, the linear non-homogeneous differential equation, y prime minus 3y equals t with y of 0 equals 0, using power series. So power series, we are looking for solutions of the form y of t equals sum as n goes from 0 to infinity, a sub n t to the n. The particular solution, we found it before, the fact that the right-hand side is not just equal to 0, it's equal to t, it gives us a particular solution, negative 1 over 3t minus 1 over 9. We did that using undetermined coefficients. So let's start solving this equation, y prime minus 3y equals 0, using the power series. So if y of t equals sum as n goes from 0 to infinity a sub n t to the n, then y prime of t is going to equal to sum as n goes from 1 to infinity a sub n times t to n minus 1. But I would like to have both terms, the y of t and y prime of t, as t to the n. So I notice that I have t to n minus 1. So because of that, I'm going to write t to the n. So if you think about it this way, if I rewrite m as n minus 1, then n is going to be m plus 1, right? So I'm actually adding a 1 to all the n terms that I have here. So it's going to be a sub n plus 1 times n plus 1 times t to the n. Now the question is, where is n starting from? So if we take a look at when n started at 1, this term was a sub 1 times 1 t to 0. So if here, at what point should I start to have a sub 1 and then 1 and then t to 0. Well, I should start at 0. So basically, all these terms here were we added a 1 to get t to the n, but here we'll subtract a 1 to get the starting point to produce the same terms as before the change. So if we replace y prime and y into our equation, we get sum as n goes from 0 to infinity a sub n plus 1 times n plus 1 times t to the n minus 3 sum as n goes from 0 to infinity a sub n t to the n equals 0. So both sums start at the same point at n equals 0. Both sums have t to the n, so then I can condense it into a sub n plus 1 times n plus 1 minus 3a sub n. So when does power series equal 0? When each coefficient equals 0. So a sub n plus 1 times n plus 1 minus 3a sub n equals 0, which means we can get the recursive formula a sub n plus 1 is 3a sub n over n plus 1. So if we consider a sub 0 as our first term, I can start writing all the other ones in terms of a sub 0. So if n equals 0, we get a sub 1 is 3a sub 0 over 1. So basically, a sub 1 is 3a sub 0. If n equals 1, we get a sub 2 is 3a sub 1 over 2. So if we rewrite now a sub 1 in terms of a sub 0, we get 3 times 3a sub 0 over 2, which is 9 a sub 0 over 2. So I'm writing each term in terms of the a sub 0. First of the previous one, so a sub 3 is 3a sub 2 over 3. So we get 3 times a sub 2 is 9 a sub 0 over 2, and then over 3 it would be over 6. I do not plan to cancel the 3's, so to simplify, I'm going to write 27 a sub 0 over 6, and maybe we should write one more term. So a sub 3 is a sub 4 equals a 3. So I'm using this one. So it's a sub 4 equals 3a sub 3 over 4. That means 3 times a sub 3 is 27 a sub 0 over 6, so it would be 6 times 4, 24. So it's 81 a sub 0 over 24. So now we can write that our solution, right, y of t, is of the form a naught plus a1t, which is 3a naught t, plus 9a naught over 2t squared, plus 27a naught over 6t cubed, plus 81a naught over 24t to the fourth, plus dot dot dot. So let's try to rearrange them to give us a better idea. I'm going to actually factor out a naught from everywhere. It seems like a naught shows up everywhere. So it's 1 plus 3t, then plus 9t squared would be 3t squared over 2, plus 27t cubed is 3t cubed over 6, plus 3t to the fourth over 24, plus and so on. We also notice that these 2, 6, 24 are actually factorials. 2 is 2 factorial, 6 is 3 factorial, 24 is 4 factorial, and so on. So when I take a look at this one, I remember the expansion of e to the x. E to the x is 1 plus x over 1 factorial, plus x squared over 2 factorial, plus x cubed over 3 factorial, and so on. So taking a look at our expansion, we could say that y of t equals a naught times e to 3t. So we actually found out the homogeneous solution. So if we want to find out what is a naught, well, the solution y of t, this would be homogeneous. It's a naught e to 3t, minus 1 over 3t minus 1 over 9, which were the particular solution. So y of 0 being 0 is gonna give us that a naught equals 1, 9. So the final solution is 1 over 9 e to 3t minus 1 over 3t minus 1 over 9. I hope this helps.